James Webb Space Telescope. The James Webb Space Telescope is a space telescope designed primarily to conduct infrared astronomy. As the largest optical telescope in space, its greatly improved infrared resolution and sensitivity allow it to view objects too early, distant, or faint for the Hubble Space Telescope. This is expected to enable a broad range of investigations across the fields of astronomy and cosmology, such as observation of the first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. The U.S. National Aeronautics and Space Administration, NASA, led JWST's development in collaboration with the European Space Agency and the Canadian Space Agency, CSA. The NASA Goddard Space Flight Center in Maryland managed telescope development. The Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University operates JWST, and the prime contractor was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. The James Webb Space Telescope was launched on December 25, 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first image from JWST was released to the public via press conference on July 11, 2022. The telescope is the successor of the Hubble as NASA's flagship mission in astrophysics. JWST's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combined create a 6.5 meter diameter mirror, compared with Hubble's 2.4 meters. This gives JWST a light collecting area of about 25 square meters, about 6 times that of Hubble. Unlike Hubble, which observes in the near-ultraviolet, visible, and near-infrared spectra, JWST observes in a lower frequency range, from long-wavelength visible light, red, through mid-infrared. The telescope must be kept extremely cold, below 50 K, such that the infrared light emitted by the telescope itself does not interfere with the collected light. It is deployed in a solar orbit near the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth, where its 5-layer sunshield protects it from warming by the Sun, Earth, and Moon. Initial designs for the telescope, then named the Next Generation Space Telescope, began in 1996. 2 concept studies were commissioned in 1999, for a potential launch in 2007 and a $1 billion budget. The program was plagued with enormous cost overruns and delays. A major redesign in 2005 led to the current approach, with construction completed in 2016 at a total cost of $10 billion. The high-stakes nature of the launch and the telescope's complexity were remarked upon by the media, scientists, and engineers. The James Webb Space Telescope has a mass that is about half of Hubble Space Telescope's mass. The JWST has a 6.5 meter, 21 feet diameter gold-coated beryllium primary mirror made up of 18 separate hexagonal mirrors. The mirror has a polished area of 26.3 square meters, of which 0.9 square meters is obscured by the secondary support struts, giving a total collecting area of 25.4 square meters. This is over 6 times larger than the collecting area of Hubble's 2.4 meter diameter mirror, which has a collecting area of 4.0 square meters. The mirror has a gold coating to provide infrared reflectivity, and this is covered by a thin layer of glass for durability.